So 11.6, it's analyzing data. Now, a little bit of vocabulary. When you hear the phrase measures of central tendency, if you see on a test, use the measures of central tendency to answer this question or something. We're talking about basically usually it's the three M's, your mean, median, and mode. Now, what do you guys remember? When I say mean, how do you find the mean? Okay, add them all up, divide by the amount of numbers you have. Okay, mean is also sometimes known as the average. Okay, so if you're asked to find the mean, think average. Median, it's a middle number, and what's the catch here? The list of numbers you're looking at have to be in order. Sometimes they'll give them to you in order. That's so nice when they do, right? Other times, guess what? We have to put them in order, and we'll have to do some of that today. And then mode? Yeah, the number that occurs most frequently. And notice it says the most frequently occurring number, parentheses, S. Could there be more than one mode? There could be. There could be a couple numbers, both repeating the same amount of times. There could be one mode. There could also be no mode if nothing ever repeats. Okay? A couple of more vocabulary words. A bimodal set of data has two modes. So if you do have something with two modes, it's officially known as bimodal. I don't know that you'll really see bimodal in the homework, but. And then we're also going to talk about outliers. Do you guys have thoughts about outliers? I mean, in my brain, I kind of think outlier. It is what it sounds like, but I don't know if everyone thinks like that or not. An outlier, it's a number that
doesn't really correlate.
Okay, doesn't correlate with the others. It lies out and away from the rest of the others, right? So it's a number that is either really low compared to all the other numbers or really high. I don't know. Can we talk about like Sesame Street or Mr. Rogers and which number doesn't belong? You know. No? Okay, maybe not.
What through my head is the Sesame Street theme song.
Well.
I don't think I've ever watched Sesame Street.
What?
Okay. So, example 1 right here. Now, you guys know, and you've known for years, the basics of how to find mean, median, mode. We're going to do this example with a frequency table. Okay? So you need to understand what this frequency table means and how we'll go from there. The frequency table shows the number of job offers received by each student within 2 months of graduating with a mathematics degree from a small college. What are the mean, median, and mode for the job offers per student? Now, are you looking at that frequency table? Are you understanding what they're providing us there? Okay. The 0 job offers 2 students. What's that saying? 2 students had 0 job offers. 2 students had 1 job offer. 4 students had 2. 5 students had 3 job offers. And 2 students had 4 job offers. So when we go, and there's a couple of different ways we can do this, but I guess eventually when we do median, we have to list these numbers out, don't we? Let me, I'm going to come back to mean here in a moment, if you don't mind. I mean, eventually we're going to be finding all 3. Mean, median, and mode. I'm going to go out of order. I'm going to find median first. In order to find median, what do you have to do to find median? Officially, at least. It's the middle number. So we're going to have to list all the numbers in order, right? Well, what do we know? What are we trying to find? We're trying to find we're talking about job offers per student. So the first numbers we're going to have. 2 students had 0 job offers. So what's that mean we have? 0. There's 2 zeros in the list because 2 students had 0 job offers. And then we know that 2 students had 1 job offer. So 1 and 1. And then what?
2 and 2.
4 students had 2 job offers, so we're going to list 2, 2, 2, 2. That was 4 twos. 5 students had 3 job offers, so now what do I need?
3 5s.
Should be 5 3s, right? Because 5 students had 3 job offers. So each of these numbers is representing the job offers per student. And lastly, 2 students had 4 job offers. That's the data my frequency chart is telling me. Are you understanding that? Now, with that in mind, how am I going to find the median?
I put my fingers in.
Okay? We're going back to our elementary ways, right? And there's nothing wrong with that. Take your fingers, right? Pair them up, 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 pair them up. Eventually find the middle, yes? Another option, how many numbers are there listed here? Has anyone counted? There's 15, which, by the way, if you add this right here, there should be 15 because there were 15 students represented in that frequency chart. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I should have 15 values represented. So another option, what's the middle of 15? 7.5. So if you count in 7 from either way, the 8th value is also your middle value. Did we find it somehow or another?
Oh. I got
Did we get a middle number there? So we have a median of 2. Now, depending on your skill level, if you want to argue and say, I didn't list all my numbers out, Ms. Sargent, and I still got the right median, I'd believe it. It's doable. If you look, if you kind of count in here, okay, there I'm counting in 4, you kind of work with your frequency table, it would be doable. Maybe a little more confusing, but doable. Let's go ahead and do mode while we're here. Why not? Oh, I know. Before we do mode, median. What if we had an even number of numbers and had 2 middle numbers?
Don't you divide them?
You add them and then divide it by 2.
Add and divide by 2, right?
I was on track.
You're not going to have 2 medians. You're going to basically find the average of them. You're going to find what's in between them. You're going to add them and divide by 2. Does that sound a little familiar? Okay. Now, okay, mode.
Do you use that set or do we have a different set?
Nope, were you doing the same set? 3, why 3?
That's I use it the most.
Okay, so if you look right here, 1, 2, 3, 4, 5, yes? Or, could the frequency table help you here? Yeah, there were 5 3s. So my mode is 3. Okay. Okay. Thoughts about the mean? I see calculators being grabbed. We're going to
Add them all up
add them all up.
and divide by the number that's there. And we count the zeros as
And
the
we-
number that's there.
Zeros do matter. So we're going to add them all up and we're going to divide by 15. Now, silly question, but how are you adding them up?
Don't you only have to do one of them?
Are you looking at your median list and doing 0 plus 0 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3 plus 3 plus 3 plus 4 plus 4? You could do that, yes. I'm not saying there's anything wrong with that. Works perfectly fine for me. What's the other option? Can we do something looking at our frequency table? Could we look at the fact that there are 2 zeros, so 2 times 0, plus 2 1s, so 2 times 1, plus 4 2s, plus 5 3s, plus 2 fourths. If you don't like what I just did and you're saying, what? Then forget what I just said. You don't have to use that. Go back and add all the numbers we have listed in our median listing. Now, do me a favor. I do want to know what does my numerator add up to be here? 33? And then we're going to take that 33 and divide by 15. And what's the calculator going to give us? 2.2? Was it exactly 2.2? Okay. That's what I have written down in my notes, but I didn't work it today, so. This is review, yes. I mean, maybe the frequency table is a little bit new, but in all honesty, do you have to think of it as a frequency table? No, you can go old school and write it all out longhand. I'm trying to give you options here. Okay, mean, median, mode. Know which is which, right? Know how to work those. Does it make sense that all these answers are very similar? Mm-hmm. It does. Okay, because they are all measures of central tendency. They all give us an idea of the middle of the data, just in different ways. Now, for the sake of time, I'm going to skip the next example, just because we'll have more practice of mean, median, well, median, I guess, but I feel like you guys have the basics there. And I'm going to go down here to identifying an outlier. So right here, as we look at example 2, this is our opportunity to talk a little bit about outliers and what they mean and how they can affect things. Which is an outlier for this data set? Are you seeing it? And I was trying not to read them out loud at first because I think it's more helpful if you look through them, but 56, 65, 73, 59, 98, 65, 59. All the others are what? 50s, 60s, a low 70, and then you have 98. So 98 would be an outlier, wouldn't it? And not every group of data is going to have an outlier, but 98 is, what, 25 higher than the next value here? So that's a pretty good outlier. Now, okay. Sorry, I was confused for a moment. Okay, suppose the values in problem 2, so in the one we just talked about, are the data for these situations. Would you discard the outlier? In other words, would the outlier affect your data and you would want to throw it out, or would it be okay to leave in? So, what if these values, these 50, 60, 70, and 98, what if this was the water temperature of a lake at 7 locations? Would you discard the outlier as we talk about mean, median, and mode? Or would it be okay to just leave it in?
Discard.
Discard? Why?
That would affect the rest of the data.
Yeah, it's going to affect the rest of that. Isn't that, if we look at our average, our mean, isn't that going to pull the mean up? And what do you think? Is that outlier probably true?
Probably not.
I mean, do you think you had in a lake all these 50s, 60s, a 70, and then a 98?
Either is right in the sun or some heat there. It's like,
I mean, I'm not saying it's not possible, but you've all been in lakes. They're not that warm, are they? Even on warm days.
Even when there's
It was measured when
Okay, so this is one where, would you discard the outlier? Yes, you probably would, okay? It's unlikely that the water temperature, even though it could be warmer in sunny spots or whatever, it's unlikely it's going to be warmer by 25 degrees. So on example A, I would say yes. And I'll write down a little bit of explanation. Unlikely. The water temp would be 25 degrees warmer. So that was probably a misread thermometer, something weird in the area affecting it. Unlikely though. Okay. Now, those same numbers that were just lake temperatures, water temperatures for the lake, those same numbers are now the number of customers in a restaurant each night in 1 week.
That's Friday.
Yes. No.
Okay. So I'm hearing that's Friday, that's Saturday. What are you guys trying to say? Is that a legitimate possible number, maybe?
Yes.
That's their busy night, right? Whatever,
Texas Roadhouse on Saturday.
Texas Roadhouse on Saturday, any restaurant yesterday on Mother's Day. How's that, right?
That's not true.
Okay, most restaurants on Mother's Day yesterday.
I don't know.
Okay, me and
It's like a 2-hour wait.
Okay, so the point being,
Anywhere on Mother's Day.
would you throw this outlier out? No, probably not, because as we mentioned, 98 would represent the busy night of the week. So I'm going to say no. Hey, listen up. Likely represents busy night of the week. And who knows, maybe their busy night is Wednesday night because they have some real good sale or they have a band in or
Karaoke night.
Like Wednesday.
so.
I say I was not busy yesterday. So.
Now, one thing I want to mention, and I can't remember exactly how it happens in homework, because as I said, I'm trying to make sure I hit a little bit of everything today. I don't feel like I need to really hit a lot of this hardcore because I feel like it's familiar stuff, okay? But you might be asked to, okay, find the mean median mode of this data set. You can do that, right? Now, what if it says, find the mean median mode of this data set without the outlier? Do you understand what you would do there? You would toss the 98 away and then find the mean median mode of the remaining numbers. So just if you're asked to do that, kind of be aware there, okay? Now, okay, backside. This is the section I'm changing up what we're doing. Okay, so we're not going to compare the data set. This is where we're going to talk about box and whiskers. Okay. So, now I will go through a little bit of vocabulary up here. Range, not talking domain and range, but the range of a data set is how wide that set is, so to speak. And so it's the difference between the greatest and least values. I don't know that you'll have to find range any today, but if you do, realize you're doing biggest value minus smallest value. If you order the data from least to
Oh yeah.
okay. If you order the data from the least value to the greatest value, we already saw on the front side, the median chops the data in half, right? Then you've got a low half and an upper half. Well, the median of each part then divides the data you have into farther parts. So in other words, the median's the middle one, yes? We can also take the median of each of the bottom piece and the top piece. And these are called the quartiles. And this is important for a box and whisker plot. Because the idea is the median is the middle one. And then you've got a lower quartile, so the median of the bottom half, and an upper quartile, the median of the top half. I don't know that you'll be asked interquartile range. I don't think I saw it there. But if range is biggest value minus smallest value, Interquartile range is biggest quartile minus smallest quartile. Okay? And then down at the bottom, we're going to talk about percentiles. I do need to get down to example 4 before today ends and talk about percentiles. Percentile is a number from 0 to 100 that you can associate with a value x from a data set. This shows the percent of data that are less than or equal to that x value. Now, okay, this table shows average monthly water temperatures at 4 locations. We are not, as I said, we are not going to compare the water temperatures. Okay, I'm changing this on the fly, but we're going to do a box and whisker plot. And in order to do a box and whisker plot, I'm going to pick a city. And I think the one I liked earlier, I was going to do Dauphin Island. Okay. We're going to do a box and whisker plot of Dauphin Island, Alabama. Okay? That's our plan. So if you look at this later and say, what were we doing? Mrs. Sargent changing everything up. Now, in a box and whisker plot, you need 5 pieces of information. You need the median, you need the quartiles, and you need your least and your greatest value. What do I have to do to find the median? No, not add them all up. That's mean. We have to have them in order from least to greatest. So the first step I would see on your paper for a box and whisker plot is we got to put them in order. So here we go. We're going to work together on this. I already have it written down here, so I'm going to make sure we stay on track. Okay, what's our lowest number for Dauphin Island? And I do not see a problem, folks, with checking them off as we go. What's next? 53. 56. 60. 62. 70. 72. 75. 80. 82. 84. And 84.
So do you have to have 284 spots?
Yes.
Because I remember a while ago I was told you didn't have to have it. Or is
No.
that just for certain ones?
I'm not sure what that would be for. If there are repeats, you do need to list them. Okay? If there are repeats, you do need to list them. Now, this is me, and I want to make sure I did this right, and I don't get ready to mess up the entire problem. Here's what I'm going to do. How many problems were in the original? Oh, was this January through December? There was 12. So what am I going to count and make sure of before I continue? Did I write down 12 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So unless I botched it and wrote a wrong number, I feel confident that I'm on the right track. Are we okay with that? Okay, so first thing I want to do is I want to find the median. How do I find the median? Okay. You're going to count into the middle, right? You can count in 6 either way if you want. So as you start pairing them up and counting in, we eventually get to the point that my middle number is not on this list. Okay? On the front side, we had an odd number of numbers. There was a middle number. On the back side, we have an even number of numbers. How do I find my median?
Don't you take the number and between the two?
Okay.
70.
Okay? So given on the situation, can you maybe eyeball it and say, oh, well, I know what's in between 70 and 72. That's 71. In certain situations, that's easy to do, isn't it? In other situations, is that harder to do? It is. And so, and I'm actually going to bring it over here just because I don't want to take up my room. But in order to do the median, my plan B could be 70 plus 72 divided by 2. 142 divided by 2, which is 71. And you know what? I'm going to, oh, shoot. Okay. So this is 71. And that is my median. There is a possibility, I don't know what the Math Excel uses, there is a possibility that they could call this quartile 2. They could call it your median. They could call it quartile 2. Just an FYI. Okay. Now, we have that. Now we need to find the lower quartile. Lower quartile says, forget everything above the median. Okay, we're not going to use the median. And even if the median was a number in the list, you don't use the median. Use the numbers below it, numbers above it. So we're going to use everything below the median, which is my 51 through 70. What's the middle of those numbers? What's the median of the lower half? Or where is the median of the lower half?
58.
Okay. We've got 6 numbers down there. Count in 3. And when we count in 3, what is in between 56 and 60? That is 58, isn't it? And that is your lower quartile or quartile 1. And sorry, I'm not very organized, but in case you need it, I'm going to put the math over here. In order to do the lower quartile, 56 plus 60 divided by 2. $116 divided by 2 was that 58. Guess what else we have to find? Upper quartile. So now I block off the median and everything below it. So now 72 to 84. Where's the middle of those numbers? Not 82, but in between 80 and 82, right? So that's going to be 81. That is my upper quartile. Why I just wrote UP, I don't know. That is my upper quartile, also sometimes known as quartile 3. Are you getting the idea there? So in order to do the upper, $80 plus 82 divided by 2. 162 divided by 2 is 81. Okay. For a box and whisker plot, I said we needed 5 things, right? You got 3. These are the hard 3 to find, if you call this hard work so far. The other 2 numbers we need are the least value. What's my least value? 51 is my least value, so my smallest value. And we need our greatest value. What's our greatest value? 84. Okay, guys. Now, I've got to do the box and whisker plot and get to quartiles real quick. In order to do a box and whisker plot, you need a number line. My number line has to count at least as low as 51 and at least as high as 84. In Math Excel, realize they're going to be giving you multiple choice here. But if I set this up, trying to decide how I can 50. Can I count by twos and make it? I'm going to try counting by twos. Hopefully I don't regret this. 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84. I made it. Oof. Now, generally speaking, when you do a box and whisker plot, we don't usually, it's not how I've done it in the past, I don't usually put my box and whisker plot on the number line. You usually see it above or below the number line. So I'm going to put a dot above where 51 should be. I'm going to put a dot above 58. I'm going to put a dot above where 71 should be. Same thing at 81. And same thing at 84. The middle three dots, your quartiles, so your median and your upper and lower quartiles. I guess I had you guys put dots. You can also make those lines. Those are going to form my box. So the left end of my box is at 58. I'm going to have a line inside my box at 71. And the right end of my box is at 81. That's my box. And then guess what the outside dots do? They connect to be my whiskers. And there you have a box and whisker plot.
I resemble more of a volleyball net than a box.
Okay. Now, what this will tell you guys, those points broke my data into fourths, right? A fourth of the data was below 58. A fourth of it was between 58 and 71. A fourth is between 71 and 81. And a fourth is between 81 and 84. This kind of tells you where a lot of the data is. There's a lot of the data in the middle half because those whiskers are pretty short, aren't they? So a lot of the data falls into the middle half right there. But that's kind of what you're looking for. Okay. I know I've been being quick today. Questions about the box and whisker plot? Because I also know you probably haven't seen these since middle school. Hopefully you saw them in middle school. So, I don't know. Now, we got what we need there. And if you didn't see them in middle school, the good news is I don't think they're difficult. I mean, you find the median, you find the lower median, you find the upper median, and you grab the smallest and biggest values and go from there. Okay? Come see me if you have struggles with that. Now, we're not obviously going to compare the 12 temperatures. We're not doing the comparing data. I'm replacing that with box and whiskers. I do need to talk about finding percentiles. Okay? Percentiles, a little bit different than percents. If you look back at the top of the page, percentile is a number from 0 to 100 that you can associate with a value X from a data set. It shows the percent of data that are less than or equal to X. So, right here. First of all, notice they were so nice. Here is an ordered list of midterm test scores for a Spanish class. What value is at the 65th percentile? So we want to know what value marks the point where 65% of the data are less than that value. Now, first thing we need to know, how many scores are here? Agree? Give people a moment to count. Okay, we can agree there are 20 terms, yes? So what we need to know is what is 65% of 20. But because that's going to show us where the 65th percentile is. So, if you will, there are 20 terms in the list, right? Times, how do I multiply by 65%? 0.65. What is 20 times 0.65? 13. So what that is saying is the 13th term marks the 65th percentile. What is my 13th term? Thirteenth term is 82 if you count your list. So what that's saying is 65% of the students scored below an 82. That is the 65th percentile. So our answer here is officially 82 because the question was, what value is at the 65th percentile? Well, it's the 13th value in the list, but what happens to be the 13th value in the list is 82. Okay. Your homework is a lesson 11.6 in Math Excel. I will say, think about the type of lesson we have. Please listen. I say there are only 8 problems. I think that's what it was. However, when you start talking about mean, median, mode, some of them have multiple parts. So I solve things with lots of parts. But it's all stuff we've talked about. Mean, median, mode, outliers, box and whisker plots, percentiles. So hopefully I've given you guys a good place to get yourself started there.